We're going to work with the exponential function y equals e to the x in this lesson, and to begin we're going to work with the parent function y equals 2 to the x first. So just as a reminder, those exponential functions, this is a parent function. We should be able to do this one pretty quickly. So we're going to start here. We're going to put a -2 in, -1, 0, 1, 2, and a 3 in. And that's our parent function for y equals 2 to the x. We connect our dots, make my line just a little bit thinner. And this is not new to us at all. We are going to get closer and closer to the x-axis, but never quite touch it or cross it. Sometimes we draw the horizontal asymptote all the way with a highlighter. Sometimes we just draw it where it really pertains. See, it really just pertains on the left side of the x-axis, but sometimes I draw it all the way across. The important thing is that you're drawing using that highlighter to draw your exponential, your horizontal asymptotes with your exponential functions. The domain is -infinity to +infinity. Our range is 0 to infinity. Y-intercept is 0, 1. Our x-intercept does not exist for our parent function, and the asymptote is y equals 0. If you can keep up with me and you can graph that function that quickly, that's a great sign. Now, we've also graphed y equals 3 to the x. In practice, we might have graphed other bases, y equals 1/3 x. So really all we're going to be doing here is graphing y equals e to the x. So what is e? E is a value. It is approximately 2.718. It does keep going, but I go out to 3 decimal places. It's approximately 2.718, and it's sometimes called the banker's constant. And we'll be able to talk a little bit more about that when we work with logarithms. So they call it the banker's constant. Like pi, it is an irrational number. So it is irrational. I'm going to show you real quick on my calculator how to get to E on your calculator. So I'm going to go to my camera, and I've got Shift, and then I'm going to go to this LN button. See the e to the x? That's what I want. I'm going to go e to the first power, and I press enter, and there's your 2.718. Now it keeps going, and it looks like there's a pattern, but there isn't. It's an irrational number for sure. If I wanted to calculate e squared, I would hit Shift and then the LN button that brings up the e. Then I would place a 2 in the exponent, and I'd get e squared. And e cubed, I could even do e cubed. Heck, I could do negative exponents. So I could do a -1. I could do a -2. And there is a reason why I'm doing all of these. I'm going to come back to it. So do you see these values? Hopefully you're writing them down, or you've got them on your calculator that you'll be able to refer to them as we go through. There we go. As we go through graphing. Okay, so let's go back to, no, not that. Let's go back here. And let's do it. We've got y equals e to the x. E to the x. Matter of fact, I'm gonna write down e to the first power is approximately 2.718. E squared is approximately, I'm just gonna put 7.4. E cubed is approximately 20.1. I think we put an e to the -1 next. E to the -1 was approximately 0.4, and e to the -2 was approximately 0.1. And you can see as my negative numbers get bigger, this decimal will get smaller, smaller, and smaller. Okay, y equals e to the x. Well, when we put a -2 in, we get 0.1. When we put a -1 in, we get 0.4. Make the dot big enough and you can't really tell the difference, right? When you put a 0 in, e to the 0 power, that's 1, because anything to the 0 power is 1. When you put a 1 in, we get about 2.7. So when you put that 1 in, e to the first power, you get 2.7-ish, so in between 2 and 3. And when you put a 2 in, 7.4, so in between 7 and 8. So it's important for you to know, very important for you to know these values so that you can graph the parent function. So you need to know that e to the first power is 2.718. You need to know e squared is between 7 and 8. That's really what you need to know. For this graph, we still have a horizontal asymptote at y equals 0. I'm going to show you y equals 2 to the x so you can see what's happening here. So here's y equals 2 to the x. So y equals 2 to the x is going to be on the outside. It's going to be to the right when x is greater than 0. But when x is less than 0, it's going to be just sitting above. So they cross right at that y-axis. So here's your y equals e to the x. The domain is still negative infinity to positive infinity. Our range is negative infinity to 0. We still have a y-intercept at 0, 1. We don't have any x-intercepts, and our asymptote is also y equals 0. So this is a new parent function. New parent function. New parent function. On the graphing calculator, let's take a look at these. So I just told you where 2 to the x is going to sit, right? Y equals 2 to the x. It's going to do something like that. And then y equals e to the x is underneath it, is going to cross there, and it's going to come on the inside. Where would, let's say y equals 2 to the x, and this one is y equals e to the x, where would y equals 3 to the x be? Where would y equals 3 to the x be? Well, you can use your graphing calculator if you want, and you can try it. I'm going to fix this little drawing here because my blue was good. My blue didn't cross over the red. We're good. So what's going to happen here? Y equals 3 to the x is going to be on the inside. So it's going to be even closer to the y-axis, and it's going to be under the blue. All of them will have an asymptote of y equals 0. All of them will have an asymptote of y equals 0. I encourage you to practice really putting this into your graphing calculator and comparing all three